So the next problem number 18. The period of oscillation of a body of mass m1 suspended from a light spring is t. A string is there, the weight of that is the mass of this the mass of the spring, it is m1. It is m1. And it is suspended from a light string and its period is capital T. It is given when a body of mass m2, other body of mass m2 is tied to the first body. To that I'll draw a rough diagram. This is a light string. It is the spring, so we'll draw the spring here. That spring, the mass m1, it is attached and its period is t. When a body of mass m2 is tied to the first body, this is the first body and the body of mass m2, it is tied to the first body and the system is made to oscillate, that it is oscillating to and fro, that is up and down, that is to stretch, it will perform the oscillation. The period is 2t. The combined system, that is when the two masses m1 and m2 are added together and then system is oscillating, then the period is 2t. So compare the masses m1 and m2. We have to compare the masses m1 and m2, not the combination of m1 plus m2. So here we'll write the given data that m1 for mass m1, the period is given, it is t. So for m1 and m2, m1 plus m2, you can write the period is t again. So the next is, here this is m1 plus m2 and when the two masses, that is m1 and m2 are tied, then the period is 2t. So we have to write here 2t. What we have to find? Compare the masses m1 and m2. That is compare m1 and m2. That is m1 by m2 ? We have to find this. Now we'll solve this. The time period of the spring. What is the formula for the time period of the spring? Time period of the spring it is, the formula is T is equal to 2 pi under root of m by q. That is, we can write T is directly proportional to root of m. It is, if this 2 pi is the constant, this k is the constant, so we can write T is directly proportional to mass of the body, root of mass of the body. So what is the case 1? For the first we have, therefore we can write, firstly we can write T is directly proportional to root of m1. This is equation number 1, suppose. So this is the given in the first case, that period of the oscillation of the body of mass m, that is when the mass m1 is attached to the spring, single mass m1 is attached to the spring, then the period is t. So we have written here T is directly proportional to m1. Then the assembly. In the second case, what happened? m1 and m2 together join, that is together attached to the spring, and it is oscillating. So period is 2t. So we can write for the second, the period is 2t. It is directly proportional to root of m1 plus m2. It is equation number 2. When only m1 attached and here you can write when m1 and m2 both attach, right? So this is equation number 2. So here further divide 1 by 2. So you can write t upon 2t is equal to root of m1 by m1 plus m2. That is, we can write it is 1 by 2 under root of m1 plus m2. Sorry, it is m1 plus m2. It will remain as it is. So taking, I'll write this again, m1 upon m1 plus m2 it is. Taking square on both sides. So this will become 1 upon 4 is equal to this term, it will come out of square, so it is m1 divided by m1 plus m2, right? So just simplify it, m1 plus m2, that is equal to 4m1. That is, we can write m2 is equal to 4m1 minus, that is m2 is equal to 3m1. That is, we can write m1 by m2, it is equal to 1 by 3. It is 1 by 3. So this is the solution. So you can solve this.